ক্লিক করেন তো যে কোনো একজনকে এখান থেকে। না, আপনার হাত ছাড়া নিতে হবে, পাশ থেকে দিতে হবে।
Okay, no problem.
প্রেজেন্ট করবো নাকি? কোড সহকারে দিলে হচ্ছে ইয়ে হয়, অ্যাটলিস্ট টাইমটা দেখা যায় এখানে। Hello everyone, good morning. This Hello everyone, good morning. This is Team BD, and today at the Unilever Engineers League, we'd like to present our solution about automated pallet fitting. And my name is Arif Zaman, and here is my colleague MD Naim Hussain, and here is Muhammad Mohamedul Islam. In this presentation, we'd like to first discuss the Unilever's existing engineering practice, our analysis of the operation and case study, our proposed solution, simulation, benefits, and the cost analysis. Unilever is a business driven with purpose, and the company vision is sustainable, digital, and biological. And Unilever's engineering is not an exception. They believe in sustainable engineering, digital engineering, packaging engineering, safety engineering, and they have a very concrete guideline to our Industry 4.0 revolution, which has been publicly accoladed by World Economic Forum. In the next slide, my colleague will talk about the current operation and analysis.
Hello again, this is Mohammed, and I'm going to talk about the current operational analysis. Okay, as we have visited the factory, we came to know that this process is going manually, and we have classified this process into 6 steps. For example, we can see that in the picture. First of all, the forklift driver will pick the pallet from the stock and put it in the buffer zone. Then it has to wait for a little bit, and the driver or someone has to continuously check when the feeder is empty. Then they're gonna put it inside it. So the problem is it takes too long time. That will decrease the productivity. Okay, let's see the shortcomings. As it is operating manually, it will cost more. For example, it takes around 20% time of a day shift for a worker. That's obvious that it's gonna cost more. As we can say it's less efficient because it consumes more time. And in terms of safety, we can say that the weight of a pallet and the stock of a pallet is gonna be so high. So as the human is involving in this process, so there is a risk of safety. And the other part, we can say that due to the hard intervention and the less pallet lifetime, it's less, we can say it's cost inefficient. Okay, and in the next slide, my colleague will talk about thoughts behind our proposed solution and the other part as well.
Thank you, Mohammed. Hello, everybody. From an engineer's perspective, after having a very distinctive problem and the shortcomings that it comes with, we started off with brainstorming. And as everyone else, the first thing came in mind was robotic arm. And then we considered these as a viable options. But later on, when we considered deeply, we came up with the shortcomings that doesn't make it to be a very reliable options in here. So in terms of space, the current operation, the space of current operation, the 3-axis movement isn't okay. Okay. In terms of space, the three axis movement of any robotic arm takes to lift such high pallet stack takes a lot of space, which is not available in the current floor plan. The sorry, I have to start off. Okay.
It's okay. Just continue.
So from the brainstorming, the first obvious options of, was robotic arm, and then when we dig into these options, we get to know the shortcomings that it comes with, which is in terms of space. Any three-axis movement requires like enough floor plan to be able to move. But here we have a constraint which is not feasible for a three-arm movement of any robotic arm. The price of any robotic arm with such precision movement is very expensive, and the maintenance requires additional cost. Then we considered about guided forklift, which to feed, but the forklift isn't a viable option because it makes the process redundant. We already have an AMR unit to bring the pallets to the buffer zone, and then involving another autonomous vehicle in that platform makes it redundant, and also it's not time efficient. It's almost the same as of the current existing procedure. So, and the cost involved in introducing any autonomous vehicle is very much, and the maintenance of course takes labor force, and the cost involved in is high as well. So we looked for something that's compatible with the existing infrastructures and also goes with the vision that Unilever has towards Industry 4.0 revolution. So having everything in mind, we came up with a solution of automated pallet filling station. And our station, to give a perspective of the to put a clear perspective, here is a visualization of the entire filling station here.
Click there for mouse control.
So the present with this little bit, okay. So separately can I color?
No worry, you can put a description
Okay.
just as it is. Fine. Then shut it the next again.
To put into perspective, it's a last click through. To put into clear perspective, here is a 360-degree visualization of the automatic pallet filling station we are talking about. To introduce the detailed parts of the system itself, here we have the AMR conveyor interface, the most important part, which we terms as. Okay, I'm not in mood now.
Same was everyone, so just.
Yeah.
So নোট দেখলে হয় কি distraction তৈরি হয় just
No, I mean, it's the key.
Gamer. So for this thing, we have did research on Milvus, which is a current supplier in Unilever Turkey, and we found out that there are 6-7 different types of
Okay,
gamer.
we have
and
it.
we have
I have it in mind. Okay. To introduce the parts of the system, the parts that involved in the system, it starts with a receiving end, which is AMR conveyor interface. So this is the most interesting part. Yeah, this is the most interesting part because this is the part where the pallet sticker being received and transferred to the conveyor itself to be able to deliver. And it's compatible with both manual and AMR operation. And AMR, it's compatible with all the kind of AMR that Milvus supplies to. Milvus, a supplier of Unilever, has in the existing practice. And then there is this turntable to facilitate facilitate the possibility of putting the pallet stack to the conveyor belt. We have the intelligent buffer conveyor, which
Go on.
okay, we have the intelligent buffer system that can accommodate 4 pallet stacks, and the whole system is completed with the cart conveyor, sensor, and safety fences and all. Our automated pallet feeding station perfectly fits to the existing floor plan. It keeps the area of operation clean, and the receiving end is very much accessible with almost anything, including manual operation, AMR operation, and also guided vehicle operation. And as you have already seen, the current operational procedure involves 6 different stages. We comprehended it to just 3 steps. Out of them, 2 is practical, and the other one is the internal analysis by the logical units. It starts with receiving the pallets in the AMR conveyor interface, which then guided to the turntable where the logical analysis decide whether to put it to the conveyor, intelligent conveyor, or to feed it directly. And the next part where the actual feeding happens is the feeding the dispenser, depending on the scenario. And then you get it.
Alright, so as an engineer, we believe that an idea is not an idea until it is implemented. So we decided to try out some simulation on the app software IO. And we have thought of this in the most realistic possible way, which is in case by case basis. On the first case, we can see that if the dispenser is empty, our AMR receiving interface can pick up the pallets and directly feed into the dispenser. On the second case, we can see that in case we need continuous feeding, which is one after. So once the last stack inside the dispenser is completely dispensed, then our PLC system will guide the next available pallet, which can be either from the intelligent buffer or can be directly from the AMR interface, and depending on the availability. And on the third case, we can see actually how this intelligent buffer zone thing works. And we can see that the turntable can turn around and send the pallets into the intelligent buffer, or in the fourth case, we can see how the pallet's gonna be from the buffer zone to the dispenser once again.
As of now, we have seen. No, exactly. As we have already seen the problem description, the shortcomings of the current operation, and our proposed solution, it is pretty much clear to everyone by now that our solution is simple, compatible, feasible, safe, and cost efficient. The solution talks itself. No. Okay. As we have already seen the problem description, the shortcomings of the current operational procedure, and the solution that we have proposed, it is pretty much clear that our solution has much more to offer than the current operational plan. It is the solution talks itself. The simulation or the solution? The solution talks itself. The solution talks for its. The solution talks for itself. No, it speaks for itself. The solution speaks for itself. Yet again, Yet again, I want to mention that our solution is simple, compatible, feasible, safe, and cost effective.
And to describe the benefits, I would like to start with the simplicity of our solution. Our solution is the least complex of all the alternative methods that can be used in the feeding process. It doesn't require extensive training to control and manipulate. And it's very much compatible with the existing infrastructure, and in case with the future upgradation toward the roadmap 4.0, such as IoT based upgradation, our system is completely upgradable. And then it's feasible. All the equipments we are using is widely available at the market at a very competitive price, and the installation can be done with the engineers by Unilever without any complicated procedure. And of course, the safety. Of course, as you can see, we have introduced a fence around our solution, and it doesn't involve any manual or human intervention, so it's completely safe in the operational area, and there is no unguarded mobile elements, that thus it's completely safe and does not involve any risk. Of course, last but not the least, it's very cost efficient, and in no time my colleague will describe the details about the cost.
Hi, we came up with a list of the basic equipments that is necessary for our proposed installation. So whenever it comes to purchase the equipments and installation, we provided the information about the price, capacity and dimension, if it fits in the buffer zone, I mean in the plan, and also possible supplier where we can buy this equipment.
The cost analysis part involved two different calculations, which is pretty much one. So for now, as we have got the information that the current operation, the manual operation, take 20% of one lever's shift time to operate, and which leaves us the operating cost of €26 per day per shift. And to round it up, it saves us, I mean, it stands to €7,488 per year. So when we implement our proposed solution, we save this whole amount to its entirety with 10 times more efficiency, which is the operation capacity will be 10 times more.
And in terms of the investment payback, we have calculated that considering the procurement cost and installation cost, we can save per year approximately 8,000, which gives us a payback period of 1 year and 1 month. However, as we know about depreciation cost, and complicated is the more complicated one equipment is, the more depreciation cost it has. And because our solution is simple and very much replaceable part by part, it has a very less depreciation cost, which can also be a significant factor in consideration.
Which means we will make significant amount of revenue in less than, and we will start to make significant amount of revenue just from the next year of installation.
Moreover, the overall the increase in times in the operational productivity of the whole production line, the proxy values calculated can be far more, which can give significant return.
So it's been a pleasure to be able to present our solution in front of you.
We believe the solution that we have presented is the best solution, and we are looking forward to see that this solution is being implemented in the practical operation floor of Unilever.
Thank you everyone for your time and attention, and please feel free to ask us any questions or if you have any comments. Thank you. Okay, first thing